I'm going to tell you a story that you might be familiar with it because it's probably happened to you or to someone you know. So you were developing something and you went through all the battles to figure out, are we going to use framework A or framework B? Are we going to be like super functional or not so functional? Are we going to be pragmatic about these or not? Blah, 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 blah. Tools, databases, then problems, problems, problems. You finally coded your thing, you deployed it to production. And then you go home, all good, someone calls you. Boom, it exploded. Something went wrong. Usually some sort of out-of-memory error, something weird happened, and you don't know why. That's much more, like it must have happened to you or to someone you know. And when this happens, particularly in the case of out-of-memory errors, people might be asking themselves, like, how much memory did we put on the JVM? Do we even have an XMX option there, or it's just like the default? How much memory was this thing using anyways? Like, not even those basic questions can be answered. And you need to fix this. And the thing is that everybody wants answers to these questions. Everybody wants to know whether their applications are behaving well or not. And when they don't, they want to know why. Like, I couldn't find yet anyone who says, oh, I really, really don't need monitoring or observability at all. They need it, but there is always so much more stuff to do. There is always a feature that needs to be fixed right away. There is always this thing that the sales guy said that they're going to give it to this customer so that you can finally close this deal. So you need to do that first. And observability monitoring always comes to the last, because that is only going to make the developers happy, because then they will have a better time fixing and figuring out these things. So it so happens that very often I find myself having a conversation with people who want to fix this problem. And during those conversations, there are 4 things that usually come up, 4 things that make people or keep people away from instrumenting their apps or having some sort of observability. So what I wanted to do today, besides blinding you with the green, is to try to go through these 4 blockers and see if I can help you unblock some of them. Okay? You might be stopped right now in one of those places. By the way, can you raise your hand if you are already monitoring the apps that you're running on production today? Because let me tell you one thing. We are running a monitoring company, and right now there is one microservices we have running on production that we are not monitoring. Because it's not on the JVM, it's some Node stuff, and Kamon is Node, like whatever. That's for, I'm not going to say the bad word, but okay. So it just happens. Like, we didn't have time to develop some Kamon port for Node.js so that we can monitor that or explore, so we did it. Like, we're guilty of that. So there's no shame on not having the monitoring. And what we will try to do today is help you figure out how you can solve that, or at least what are the first steps that you can take to solve that situation. So the first problem is that this whole thing is unfamiliar. And we are all bombarded every day with tweets and retweets about things and buzzwords. And now everybody heard the word Prometheus somewhere. Like, yeah, it's there. Like, everybody should be somehow using it, even though you are not really sure about what is it supposed to be doing or how do you connect with it. Actually, you don't even connect with it. And then, of course, there's Grafana and Zipkin and traces and stuff. Like, there is so much out there that it's hard to sift through all of that and figure out what are the basics, what are the things that I actually should know to start using these, what are the concepts that repeat across all of these tools, so that you can have a better idea of how to compare or what things you should be trying to understand. Like, I want to understand, how do I do metrics on this thing? What is Prometheus? Is it like a metrics tool or a tracing tool or what? So let's try to get you familiar with these concepts. The first thing that you should know is that there are 3 jobs that you need to get done when you talk about observability. One thing is to instrument your app. That's basically just gather some information out of it. Like, find a way to measure the behavior of your app and be able to put this data somewhere else. somewhere where you can analyze it and do something with it. Then, once you have that data, you need something that will help you analyze it to answer the question, is your app healthy or not? That's basically monitoring. You end up somehow measuring some signals that come out of your app. You create an alert out of that, and you can answer the question, is it healthy or not right now? And then, after you have that situation and something actually goes wrong, and you know, hey, something is wrong, you want to figure out what is wrong. And the figuring out what and the figure out if something is wrong is achieved mostly with different tools. So the tool that we are going to talk a little bit about today is Kamon. Kamon is a tool that works on the instrumentation space. We try to help people gather all of this data and send it somewhere so that you can monitor and debug those applications. So let's talk a little bit about the instrumentation and what are the concepts that you will hear over and over again within the instrumentation side of the problem. The first is context. And we particularly talk a lot about context because we have this idea that the only thing that we propagate across systems is context. Now, that context that we're talking about, there are these three things, context, metrics, and traces. We're going to go through them. So context is basically a bunch of key value pairs. And many of you might already have some version of context running on your system. Usually, it comes in the form of some sort of request ID or correlation ID, something that you create when a request enters your system, and then you pass that thing all over the place. If you have a monolith and you, well, sounds bad, right, monolith. But if you have one of those things and you pass execution around to different threads, or if you have a microservices architecture and then one request coming out needs that it spreads out to a bunch of other services that might call some other services, you'll find this correlation ID everywhere. You just pass it around so that everybody at least logs this thing. So you can get a request ID for something that failed, put it in the logs, and then you just grab the logs and find everything that happened related to that request. So context is just that. It's a bunch of key value pairs that need to go around. They need to follow the execution of your request around your entire infrastructure, be it within the same process, jumping through different threads and so on, or through different microservices and different processes, maybe even different programming languages and platforms. So context is just that, a bunch of key value pairs. In the case of Kamon, context is an immutable map of things, a key value pair that is immutable and is the only thing, as I mentioned earlier, the only thing that we propagate around. You might hear in some other places that are talking about propagating spans or tracing headers and things, blah, blah. No. We propagate context, and then the context could have inside tracing headers, could have your tags, your additional request correlation ID, or whatever it is that you want to put there. So context is the only thing that we propagate around. Then you have metrics. Metrics, the whole point of metrics is that they help you with behavior. So the context allows you to share data across different parts of your infrastructure, and metrics allow you to measure behavior. And usually, every metrics library out there will have a version of a metric and an instrument. A metric tells you what it is that you are trying to measure. An instrument is an instance of that metric that tells you, I'm measuring that for this particular component of the app. So in this example that we have here, imagine that we have a metric called data.send. It means you are trying to measure how much data was sent through something. And then you create an instrument with tags. The tags are just key value pairs that identify from where are you getting the values for that metric. In this case, it could be an interface ETH0 from the target some node. So this means how much data you're sending to some specific node. And you can have as many tags as you like to determine from where are you measuring that data. So when you're instrumenting your apps, always think about the metric as what you're measuring and the instruments as from where you're measuring that. And that's it. in most libraries, you will find three basic types of instruments. Counters, count events, how many times did something happen? As simple as that. There is a histogram or sometimes some specializations of it. Like, for example, we have a timer, but timer is just a way of measuring a distribution of values. And there is a gauge. Gauges are usually just something you will not use a lot because they're not like that much useful, but they just tell you what is the current value of something. So if you started your app, you set a gauge to have a value of 100, it will always say 100 until you change that value. And all metrics libraries out there have a way of getting you this. There might be some difference on the implementation, but basically you need to focus on the two ones on the top. Count how many events happen and measure distributions of values when you are talking about things like latency or message sizes. And keep in mind that the importance of using these two ones on the top is that you can aggregate those values. You can sum a counter with a counter. You can sum a distribution with another distribution. You cannot really sum a gauge with another gauge and get some useful value out of that. So when you're instrumenting your apps, if you want to create things manually, think about those two, counters and histograms. Then comes traces. And I think traces are like the most hyped things lately because everybody's talking about there was open tracing and open census and zipking and Jagged, and also it's quite fancy. You see these awesome visualizations of how a request went through a whole bunch of microservices and it just looks cool. And you want that, but it seems like a bit complicated. Like there's a lot of stuff happening there. But if you think about it from a very broad point of view, a trace is just a bunch of spans, a bunch of operations, and all of those operations are related to each other. They are correlated and they have some common identifier. That's it. A trace, like the concept of a trace, doesn't exist. It's just a bunch of spans that have the same trace ID. And if you look at each one of those spans, it's just a description of something that happened in your app. And this description has two sides of the data. One thing is identification, something that is kind of mandatory to have, because each span tells you, hey, this is what I'm doing. I am a server operation, and I am a child of this other operation right here. And I belong to a trace named 1234. And each one of your services, as your requests go through a bunch of services, each one of them will collect their part of that operation. So I did this as part of that trace, send it to some central place, and then all of this data gets aggregated together, and you get that big image of what happened with the application. So you have this identification side on the span and some tags. And these tags are, again, just key value pairs with whatever information you want to put there to help you debug. So when you get a problem, these things are awesome because these things help you. Like if you use a tag to put, for example, the SQL query that you sent to a database, that's awesome. If you have a customer ID and you put that as part of a trace, then you can see, well, what happened when my request for my client, super awesome client A, had a request and it failed. So you can get that level of detail when you're using traces just by adding tags to spans. That's it. Then you will hear a bunch of names being thrown around, and I would like to somehow put them on some category. So there's the instrumentation category, the first problem we talked about earlier, which is just about getting metrics out of your app. There is Kamon, there is Cinnamon, there is part of Lightbend telemetry, but there is also Micrometer, Open Census, Open Telemetry, Open Tracing. There's like a bunch of tools out there that can help you get data out of it, but that's just a part of the problem. So when you want to monitor, when you want to look at those signals, at least to the metrics part of it, you will be looking at tools like Prometheus or InfluxDB. Even the good old Nagios is something that can help you with monitoring your app. It's a very simple monitoring, but it basically helps you answer the question, is this thing alive or not? Is like, should I be investigating something? And when you figure that out, the tools that will usually help you figure out where the problem is are your logs. So if you have something that this Elasticsearch, Kibana, and Logstash combination, that will help you. If you have traces, traces will help you. But they will help you only when you know that you have to go and investigate that something is happening there. They will not tell you, hey, you should investigate something. No, no, no. You first figure out that there is a problem, and then you go to those tools and figure out. So you will start seeing that data will go to different places depending. Well, metrics will go to this like monitoring system, and traces will usually go to this debugging systems. Now, imagine that at this point you are familiar with observability. You know that there are these three things: context, metrics, and traces. Then what? The next problem that people have is, well, yeah, now I'm familiar with that, but what should I do? Like, there's so many things that I could do. So what I'm going to give you now is a quick sort of checklist of things that you should be looking at. Like, if you have no idea where to start, you have no idea what you should be measuring, think about the things that I'm going to mention now as basic. Like, you should have these things right from the beginning, because these will help you find problems. So the first thing, sorry. We divide this into kind of three categories. First, some basic stuff that is like infrastructure based. It doesn't even care about what your application does, but it's basic stuff that you should have for any application that you're running. Then service level information that is tied to your service, to the business logic that you are running. And in some cases, if it is applicable, you could have a higher level of instrumentation where you measure your actual business logic, like the things that matter to your business. So let's try to go through that. First, garbage collection. That's kind of an obvious thing. It doesn't hurt until it hurts. Sometimes you just go and deploy something that you thought was super awesome. I'm just caching all of these things to make everything faster. And then you have a bunch of things on your heap, and then suddenly you're jumping from 50 milliseconds of garbage collection to 2 seconds of garbage collection every single minute. And then that is quite some time that someone is waiting for your service to be responsive. So I think it doesn't need explanation. Please have a way to measure how much time are you spending on garbage collection and how often are you doing garbage collection. Next thing is thread pools. We lately are talking so much about asynchronous applications and things jumping between threads here and there. And yeah, that's all cool, but how do you know whether you are actually jumping to another thread or not? How do you know if the amount of threads that you have in a given pool are the appropriate amount of threads for that pool? When you have blocking operations like JDBC calls, like, it's kind of normal for you to have a kind of bigger number of threads, because those threads are going to be sitting there all the time. They're not going to be doing anything. But when you have a bunch of asynchronous operations that run really quickly, you could have a smaller, probably you're going to use a fork join pool for that. And actually, one funny thing is, if you have a fork join pool with like 100 threads, it consumes a bunch of CPU when you have almost no work, because these guys are there trying to figure out what they can steal from each other. So you could be burning, you could be burning CPU if you have 100 threads in a fork join pool and just a little bit of work, because they don't die because there is a bit of work, but they have nothing to steal, and then they keep spending CPU trying to steal. So the only way you could figure out that that is happening is if you're keeping an eye on your thread pools. Then connection pools. You will rarely have a service that does everything by itself. Usually it needs to connect to something else. That something else will usually be a database, be it a SQL database or a NoSQL database, or something else that you reach through HTTP. So if there is a connection pool, there is a limit. You don't have unlimited connection pools. If you have the ability to do 30 requests to the database, and you are doing 30 concurrent requests right now, things are going to wait. And you have no way of knowing that unless You either start grabbing the logs to see the messages about, hey, timeout while trying to acquire a connection from the database, or when things start getting slow and you don't know why. Next thing, good old CPU usage. Sometimes applications are just burning CPU without you knowing because they are kind of responsive. But turns out there is one background thread that was supposed to be cleaning something and got stuck in a loop and is burning CPU and you don't know. And sometimes things only have an effect that you can see at lower levels of your infrastructure. So please make sure you can monitor your CPU usage, which is kind of basic as well. Finally, I'm not sure, log events. Like everybody logs, but the problem, let's say, with the logs is that they are there, they're kind of passive. If you are not grepping them or looking at them, you don't know that the errors are happening. So sometimes something as simple as having a counter that measures how many error, info, warn, debug statements are there, it's enough for you to figure out that something is happening. And sometimes it's not just the errors that you need to figure out. Sometimes the debug and trace statements. I have seen several times people deploying something with trace level on because they forgot they were developing something, they ship that, and then the application goes down or gets really slow because they're logging too much. Nothing to do with business logic, just logging too much. So just having a quick count on how many log events you have per log type, that helps you a lot to figure out whether things are failing or you're just writing too many log events. And queues of all kinds. Every time when there is a queue, there are two possibilities. The queue is bounded, and when it reaches the amount of data that you can put there, it will either wait or drop things from getting into the queue, and that's something that you should care about. And if the queue is unbounded, it could simply grow until you get the out-of-memory error that we saw at the beginning. So every time you have a queue, you should be able to know, is this queue healthy or not? Especially true when using Akka actors, because at the end of the day, the mailbox in an actor is just a queue. And that queue, by default, is unbounded. So you could get an out-of-memory error just by sending too many messages to an actor. Finally, when you get to a higher level, and we're talking now like things that are specific to your implementation of your service, it is really important that you are able to trace all interactions with external services. Lately, I have been spending a lot of time talking to people about monitoring and how they face problems in productions, what is happening when they have those problems in productions. Most of the time, the problems are in the boundaries between services. You have a service that depends on another, and that one got slow. So this service is fine, but the downstream dependencies have problems. And usually, when those dependencies have problems, it all boils down to some database index that was dropped, some database that got slow, some database that became unreachable. So all of these places where you have boundaries between one service and another, or a service and an external dependency like a database, usually you need to keep a close eye on that. So instrument your apps so that you can get that information out of them. For each one of these endpoints, if you want to keep it simple, like you could get a lot of information from that, but there's this thing called like the red method. It's just try to keep the rate at which invocations are happening, the number of errors that are happening, and the duration of those requests that go to this external service. Just keep these three signals out of every endpoint on your app and everything that you connect to. Just keep that, and that will help you a ton later on when you need to start figuring out what is happening with your app. And finally, when you have all of these things, like there's a lot of things that you could be monitoring here. But at the end of the day, there are usually a number of metrics that really matter. Maybe the latency of some particular endpoints, or you just care about not having errors. Like usually there are 2 or 3 signals that really tell you whether your application is healthy or not. And you should focus on that. Sometimes one of these endpoints metrics is exactly what you need to monitor. Sometimes it's more like a business-related thing, so you should create a bit of manual instrumentation to expose those metrics to figure out what it is that matters. But don't try to monitor everything. Like, try just to figure out what are the things that, hey, if any of these 3 metrics moves anywhere, it means that our users are having a shitty experience. So we should go and do something about that. Like, sometimes if you had a garbage collection event that took 5 seconds, 3 a.m., but it didn't happen again, do you really need to wake up someone to go and check that out? Probably no. But if you have users constantly experiencing high latencies and the service is shitty for them, then you should probably wake up and do something. So not only measure the things that matter, but alert on the things that matter. It's super easy to go crazy. Oh yeah, Topo gave me this checklist, so I'm gonna put an alert on all of that so I will know when something goes wrong. And then you get so many alerts that you are gonna miss the one that matters. So you should have all of this information to help you debug when something is happening, but you don't need to alert on all that. Only alert on the things that really matter to your users, so that when you get an alert, you will not dismiss it that, yeah, it's again this shit that's always failing, and then in the middle of all of that, one day is going to be the one that you should have taken care of. So, in this topic, you will always need to iterate on this. This is not something that one day you're going to sit down and you're going to put all of this instrumentation and suddenly you're done. 5 years from now, we will just move to a different platform and we're good. Usually you will need to iterate on this. The first time you have a problem, you will figure out it would have been easier to troubleshoot this if we only had this additional information there, or if we only had these tags on our traces, or if we were only able to propagate this additional information. So keep in mind that once you instrument your apps, that's just step 1. And you need to evolve with this. As you add new features, you will probably need to add new metrics or new pieces of instrumentation that will tell you how those features are behaving. So always, always, always think, when you're releasing a new feature, how does this affect the observability of the app? Can I do something to make it better? Or every time you have a failure, figure out, is there any additional information that could help me solve this thing faster? So just iterate on it. It's not like something that you have to really think hard about that. If something seems that is going to help you, just put it there. Now, I just talked about a bunch of things to monitor, and then the next question usually is, well, man, this is hard. Like, you're telling me to monitor like 200 things and traces and metrics and all that stuff. Like, I'm never going to get to do that. Like, that's like a lot of effort that I need to put on to do that. And precisely that part of the problem is the one that we're trying to solve with Kamon. So we created this library that has basically 3 main components. The core library, which is just a library for metrics, context propagation, and distributed tracing. That's it. It doesn't know about anything. It doesn't know about Akka. I mean, it's written in Scala, but it doesn't know about Akka, it doesn't know about JDBC, it doesn't know about anything. It's just APIs for you to get a way to instrument your applications so that you can get this information out of them. Then we also have a bunch of instrumentation, and we did this as bytecode instrumentation. So you don't need to do anything special in your application for these things to start working. So when your application starts, we hook into it, and we have instrumentation for Akka HTTP, Play Framework, JDBC, and a bunch of things that are coming up. And finally, you have these reporter modules that basically hook into Kamon and say, okay, let me take that data that you collected and send it somewhere. That somewhere could be Prometheus, could be Zipkin, could be Kamon APM, could be any of the tools that are out there. And if there is no reporter available, you can go and create one yourself. So that's the whole thing about Kamon. Now, if you want to start using Kamon, like if you were using it before, it was kind of a complicated experience. And we released Kamon 2.0 like in June, I think. And the main focus for us in this new release was to make it easier for people to start using Kamon. So as of like today, if you want to start using Kamon, you only need to add a dependency on the Kamon bundle, which is a jar that has all the instrumentation we have available in there. Call kamon.init when your application starts, and if you, well, obviously you will want, add some reporters so that you can send this data somewhere outside. Now, when this was about to happen, I said this: it takes longer to decide on rules for code formatting than to install Kamon 2.0. And I thought, okay, I have this slide, I'm going to say it, but then I thought, well, maybe I can show it. Maybe I can show how this actually works, because it's actually just one line. I need to add one line. So let's try to do that, and hopefully it will not fail me today. So in this repository that you see here, there are some examples from the workshop that we ran yesterday here in Vscala. And I'm going to take just one of those services and put Kamon in there. So all I had to do for this particular case was I added the Kamon bundle dependency. I added the Zipkin and Prometheus reporters. This is just 3 dependencies that I added to a microservice. Most of the time, people think of monitoring like after the fact, after they already have an application, and they just like, man, we just like crashed the app last night, and we didn't know what happened, so we need some instrumentation right now, so that if it happens tomorrow, we will know what happened. So you add these 3 dependencies, and then when your application is about to start, you call this kamon.init. It's important that you do it as the very first thing in your app, because if some classes were loaded after you call kamon.init, they will not get instrumented. But then when you run this app, just with those, just a second, just by adding that kamon.init, you will see this lovely banner telling you, hey, you're starting the app with the instrumentation agent, and you will get, in this case, the Kamon status page, which is part of the bundle distribution that tells you everything that Kamon just did for you. So it started the Prometheus and the Zipkin reporter. It starts the JVM process and status page module. So it is already collecting metrics for the JVM, all these things that we talked about, like garbage collection and so on. And you can see here a list of all the metrics that currently Kamon is gathering for your application. And finally, down here at the end of this very long list of metrics, you can see the modules that were active for this application. So this little application that I just started has Akka, Akka HTTP, it has thread pools, logback, Scala features. It doesn't have remote JDBC or Mongo, but all of these things, all of these instrumentations are there as part of the bundle. So you just added this kamon.init, and boom, you get all these metrics out of the box. So that was really a one-line demo. Finally, the final problem that people have is that doing this takes resources. Like, this is not going to be free. You're going to pay this, and you're going to pay it in one of 2 currencies, effort or cash. So there, some of the tools that we talked about, like Prometheus and Zipkin, they are open source tools. You don't need to pay a license for that, but you need to figure out how to configure them. You need to learn how to use them. You need to learn about their domain, about the specific quirks of how to use that particular tool. We kind of removed a lot of the friction on the instrumentation side, but that is just the instrumentation side that we're doing with Kamon. So you will still need to figure out where you're going to send your data. You need to maybe, depending on what you use, spend some time on instrumentation. And importantly, you need to bring awareness to your team. If you're a team of 10 people and one of you wants to do monitoring and the other 9 just don't care about that, that's not going to go anywhere. Like, you need buy-in from the team, and that takes time. It takes time to tell them why. Why do we need to do this, and why do we need to do it now? Like, most of the time they know that they want to do it, but it's like, yeah, not now, we need to like ship this or do that, or I better just try Zio now because it's like hot at the moment instead of doing some instrumentation. So you will need to convince them to get into that. And if you go on the other side, like if you don't want to do it yourself, well, you will have to pay something. You will have to pay for the servers where these tools are running, or the subscription, or maybe even some training if you want to get that. Now, shameless plug alert, you can even do this part about where to monitor your apps for free with Kamon APM. That's a tool that we created to complement Kamon. So this is a commercial tool, but it has a free plan. So if you have up to 3 microservices, you can just start using this thing for free. And you will not need to sift through all of those metrics. Like, we just take all of this data that comes from Kamon and nicely organize it so you can go and check the health of an actor, of a thread pool, of an operation, not have to go through a million dashboards that you created or that you need to create, and you need to know the metrics to figure that out. So right now, observability was unfamiliar. Now, I guess, is not. You didn't know where to start, but now you know. You even have a checklist of things that you could be looking at when you get home to, well, not today, but more like on Monday, to start instrumenting your apps. It is kind of hard, but we are trying really hard to make it easy. And a proof of that is this simple Kamon.init that you can put on your app to get started with these things. And it takes resources, yes, but I already spent like half an hour telling you about this, so you learned a lot. And you don't even need to provision a server or anything. You could go and start using Kamon APM for free. So what are you waiting for? What is preventing you from going and monitoring your apps right on Monday when you get back to work? So if you have any comments, if you are stuck in any of these steps, you can obviously ask some questions now, and if not, I'm going to be tomorrow here all day. I really like to talk about these topics, so just come to me and say, hey, Topo, I need you to explain me this, and I will try my best to help. So that's all for today. Okay, thank you. Any questions? No? Man, you should have waited a minute for this.
Yeah, I know. Thank you. I've got one question. I saw this Kamon init right after you spoke a lot about simplicity of using Kamon and all the tools to monitor your applications. And I was wondering, why didn't you choose Java Agent, low-level Java API for all these things you are doing with Kamon?
Well, actually, that Kamon.init uses this Kamon bundle, and the Kamon bundle has a Java agent inside, and it attaches the JVM agent to the JVM that is currently running. So there is a Java agent underneath that, and you could start your application with -Java agent, blah, 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 but the problem with that is when you use it from SBT is different. When you do it from IntelliJ is different. When you want to pack a Docker image to run on your Kubernetes cluster is different. Now, this one line here will work in SBT, will work in IntelliJ, and will work on the Docker image. It's just a simpler base way of doing this. If you have Play, we have there's some special stuff going on with Play, but we have an SBT plugin specific for Play so that it will be this easy. Yeah, cool. Yeah, any other questions? No? Okay. Here.
Do you have any super interesting feature that you will put into Kamon in the future? Like something you are looking forward to?
Well, there are a couple of things that I really want to do soon. One is to show more information in this status page. Like currently it's now like, hey, we're doing these metrics, but what if we could show a partial view of the traces that just executed on this without you having to install anything. You just go to the status page and it's there. And on the other side, there's a bunch of instrumentation to be written. So we were kind of waiting a lot for this Kamon 2.0 release and to try to get it right, because there was a fundamental change on the way we do things. Before we were using Aspect Chain, now we're using our own agent built on top of ByteBuddy. And right now, after we crossed the 2.0 boundary, now the important thing is get everything monitored. It could happen that you're using some libraries that are not monitored by default, not instrumented by default, and then it's like, oh yeah, but I don't see the client spans right away. So we want to fix that. We want the first experience to be you put this Kamon.init, and everything that I talked about works not only with these libraries that I put on the slide, but basically with every major library on the JVM. If you are using Kamon or you have a library that is not instrumented by default, let me know, because we really want to hear. We are basically working based on demand. The more people say, I want this to work, we will bump it up and work on that first, because we have limited resources. Yeah, cool. We good? Good. Well, people, later down on the party, if you need anything, just ask me. I'll try to help. Thank you.